If 2023 is the first year of generative AI era, the miracles continued in 2024, like the amazing reasoning and planning capabilities of OpenAI's GPT-4 and o1, the skyrocketing of NVIDIA stock prices, the emerge of AI agents, etc. Now, we come to 2025, and the AI hype is certainly not a bubble but has become a critical success factor for all business. If your company still doesn't have a plan or roadmap to adopt AI into your existing day-to-day business operations, you probably has lagged behind too far from your competitors. This presentation will show you a framework and possible use cases for you to plan for your AI adoption roadmap. Also, we will provide practical and low-risk implementation approaches to assure quick wins and your long-term AI success. First of all, it's critical to understand that different AI solutions and use cases can have different level of complexity and risks. Here, for easy to understand, we divided such AI use cases into 4 layers according to their level of complexity and automation. As you can see here, these layers include: first, staff make use of AI to carry out individual tasks by themselves. Second, setting up internal knowledge base, or RAG, to facilitate internal domain-specific query. Third, building machine learning prediction models for different business operations or inferences. And fourth, developing autonomous agentic workflows for processes automation. Next, we will explore each of these layers in details in this presentation. For the first layer, it involves company staff using large language models, or LLM, and generative AI by themselves to perform individual tasks, like drafting email and meeting minutes, or generating reports, etc. Such AI solutions are easiest to implement. They have no preconditions to adopt and the risk level is low. The only concerns might be the leakage of internal sensitive data if the LLM is cloud-based. We are more than happy to help if you want to know more about how to address the data security issue of cloud AI solutions. The second layer involves building internal AI knowledge bases and query them through Retrieval Augmented Generation, or RAG. RAG is one of the 3 major grounding approaches to provide company internal or domain-specific AI solutions. Here you can see that the AI internal knowledge bases can be composed of both structured and unstructured data. For internal knowledge bases based on structured data like application databases, appropriate metadata about the data records must be set up in advance. Then, when users query the knowledge bases through natural language, LLM will generate SQL query according to the metadata and retrieve targeted records accordingly. The retrieved data records will then be passed to the LLM to generate the final response back to the user. In order to help you understand better, let's go through the flow with a customer product inquiry services use case. Firstly, we need to set up metadata for the target database and records. Then in step 1, user inputs the question: I need a top for an outdoor event that is not only comfortable and warm, but also casual and chic. In step 2 to 4, AI chatbot create SQL code based on metadata and searches database to retrieve related product information like product number, description, pictures, and past customer review, etc. In step 5, the retrieved data and the original question are divided into chunks to form the context, and then the AI chatbot combines the original question and the context to form a new prompt to query the LLM. Lastly, in step 6 to 8, LLM responses to user with the complete and appealing answer. That is, based on your requirements and our customer reviews, we recommend these long-sleeve blouses. I'm happy to help if you want to order. For internal knowledge bases based on unstructured data like documents, images, and websites, such sources data must be embedded in vector or graph databases to build the internal knowledge bases in advance. Then, similar to the structured data flow, when user query the knowledge bases through natural language, AI chatbot will retrieve appropriate related documents or images from the internal knowledge base and generate the final response through LLM. To successfully implement internal AI knowledge bases through RAG, you need to well plan in advance regarding those aspects like chunking and embedding methods. Use vector or graph databases, document styles and structures, etc. Also, security concerns like if the input documents or database records may contain sensitive data must be taken into consideration. We are happy to help you tackle these concerns and security risk. Please refer our contact information at the end of this presentation. The third layer involves building prediction models and query them through traditional machine learning algorithms, such as probabilistic, classification, clustering, or regression models. Here you can see that the processes are separated into two phases. First, you need to have sufficient good quality training data to train the machine learning model through either supervised or unsupervised learning against a targeted output. Then you can use the model to deliver prediction or inference based on actual data. A good example use case for prediction model is personalized product or services recommendation. For input training data, besides internal historical data, you can have other optional data sources like vendors' data, social media data, or synthetic data. After the prediction models are well trained against target results, you can feed actual data like marketing plan or customer profiles to let the model generate personalized product or services offers. To successfully implement prediction model, you need to well plan in advance regarding those aspects like select the right machine learning models or algorithms, build reliable AI models using supervised or unsupervised training, good quality historical data are prerequisite, etc. Nevertheless, security concerns like if the training datasets may contain sensitive data must be taken into consideration. Again, we are happy to help you tackle these concerns and security risk. Please refer our contact information at the end of this presentation. Autonomous agents, or agentic AI, use sophisticated reasoning and iterative planning to autonomously cooperate themselves to solve complex, multi-step problems. Furthermore, autonomous agents can integrate all internal knowledge base components mentioned in Layer 2 and 3 previously and build robust and powerful AI solutions or agentic workflow to automate those manual and time-consuming tasks that cannot be easily automated through traditional IT applications. For a detailed explanation of AI agents, please refer this YouTube video. Now let us see how autonomous agent can be applied to normal business operations. Here we use generation of leasing agreement for a property company as example to illustrate the flow. First, the user prepares the required lease data and asks the agents to generate a leasing agreement. A supervisor agent takes up the order and assigns agreement drafting agents team to carry out the tasks. Individual drafting agents team members will coordinate with each other to execute the steps, which include grasp the user input data, retrieve appropriate agreement template, and query internal knowledge bases, like rental income policies, profit targets, and tenant trade compositions, etc., to generate the draft agreement. The draft agreement is then passed on to the verifying agent team to access the risks against internal policies and rules and external law and regulations. The risk assessment results will be used by other verifying agent team member to revise the agreement and output it for next step. Finally, the verified agreement will be endorsed by a human gatekeeper, as human in the loop, to control the risk level is acceptable and the final agreement is correct. To successfully implement autonomous agent, you need to be aware of the following issues. First, autonomous agent applications are the most difficult for implementation compared with other AI solutions. Second, they require pre-built internal knowledge bases and prediction models as tools to enable them carrying out their tasks. Third, autonomous agent applications need extensive high-quality historical data to implement. Lastly, if there's no sufficient historical data available, synthetic data like vendor data or social networks can be considered. For security, how to manage agents' access is a big question for autonomous agent implementation. As usual, we are happy to help you tackle these concerns and security risk. Please refer our contact information at the end of this presentation. Now, you have a good idea of the AI implementation framework, which tell you how different AI business use cases have different level of complexity, risks, and adoption considerations. On top of the AI implementation framework, you can easily draw a low-risk adoption roadmap but also able to deliver quick wins. As you can see here, We can start with those easiest use cases in Layer 1 individual tasks to let our staff get familiar with AI solutions. Then, after some initial lesson learnt or quick wins, we can evaluate our internal AI capabilities and business requirements and try other use cases in Layer 2 and 3, i.e. RAG and AI prediction models, which can deliver higher business values. Finally, after we have sufficient AI knowledge and experience, we can try those use cases in Layer 3, i.e. autonomous agents, which can help us to continuously improve and transform our organization for long-term success in the new AI era. In between, you are highly recommended to involve external expertise when necessary and provide sufficient AI training to your staff. We are more than happy to go through this challenging AI journey together with you for mutual success. Here are the solutions and services we offer to help you mitigate your risks and assure long-term business benefits. They include agentic AI or autonomous agents development tools developing domain-specific AI knowledge base such as property management, retail, sales and marketing, asset management, etc. Synthetic data and related solutions consulting and training services to guide you selecting and executing pilot AI project, and scale and continuously improve. If you have any question or want to know more about how to implement AI, please contact our Chief Consultant, Mr. Rico Chiang. Hong Kong telephone number 9082 3965 or email rico.dogchiang@pr-data.com. Thank you.